We're going to move over to the top of page 3, where we're finding the absolute value or magnitude of a complex number. Basically, we're finding the distance of the complex number from the origin, and I'm going to show you this in a minute, and this is where it has to do with vectors. So this is page 3. Page 3. All right. A plus bi, the absolute value of that is equal to the square root of a squared plus b squared. Let me kind of show you what's going on here, just so you'll know. When you're looking at the coordinate plane, normally this is x, normally this is y, right? X is your horizontal, y is your vertical. This is different in complex. In complex, they make your x-axis your real axis and your y-axis your imaginary axis. You know how I always harp on you about label your axis, because it matters. There are different axes to label different things. We're not always in x, y. This time, we're in our imaginary. Okay? So if you jump down to the bottom and it wants us to plot these puppies, let's plot them. If it wants you to plot the letter A, which is at 4 plus I, well, let's do that. Do you see that down there at the bottom? Okay. So 4 plus I. Well, 4, I just go 4 in the real direction. 1, 2, 3, 4. I is positive, so I go 1 up I direction, and there's my letter A. It's almost just like the 0.41. Are you seeing where I'm at, Brandon?
Yes.
Okay. So I guess if we need to fill in those things, which we probably do, in the complex plane, the horizontal axis is the real axis, and the vertical axis is the imaginary axis. So on your little plane that you see on the bottom of the page there, you need to put this big R out here on your horizontal, not an X, but an R to label it as your real axis. And on your vertical axis, you need to put an I for imaginary. All right? Let's graph the next point, B, which was what? -3 plus 2I? Well, that means I'm going to go -3 on the real axis, and I'm going to go down 2 on the other. So there's your B. That's not too bad, is it? Or did I put it wrong? Oh, no, it's not a -2I. What is it?
Positive 2I.
Ugh, brain dead. Teacher? Well, if I had my eyes in. Okay. C. Let's graph that puppy. 5 minus 2I. So 5 over on the real axis. And now what? Down 2? All right, I'm feeling better now. And then the last one was D. And what's that going to be? -2, -4I. So back to 1, 2, 3, 4. That would be my D. Are you seeing how to do A, B, C, D? So let me show you what it means when it says find the absolute value of A plus BI. What they're doing is this distance right here, this is still your origin of 0, 0. You just happen to be in the complex plane. It's 0 on the real axis, 0 on the imaginary axis. When they're talking distance, they're saying how far is it from here to here? All right? And where they get their information is, well, there's this length, right? There's this length, and this makes a right triangle. This should look a lot like the Pythagorean theorem to you.
Hypotenuse. Yeah, square root of A squared plus B squared equals C squared.
That's exactly what you're doing. So you're finding this distance here, which is your C squared, which is the square root of A squared plus B squared. Is that making sense? That's where it's coming from. So the reason they call it the magnitude is because when you're talking vectors, vectors always, when you're measuring their magnitude, they start at 0, 0. And however far they go, that's their magnitude. So when you start adding vectors and doing that kind of thing, it acts a lot like this. Okay? It's not hard. It's just know that when they're asking for absolute value, and sometimes when they're talking magnitude, sometimes they'll do it with a double absolute value. They don't usually do it with complex numbers, but with vectors they do. Sometimes it looks like a double absolute value. It just means magnitude. You know, it just pumps it up a little more. I mean, it looks more impressive having the double little lines there for some reason. So now we're going to actually find the magnitude. So let's look at that first one, which was 4 plus I. Okay? What is A here?
A would be 4, right?
That is absolutely right. A is 4. What is B here?
1.
1. Remember that A and B are just your coefficient type things, right? Never include your I because you're going to end up messing up. All right? So in order to find it, we do the square root of A squared plus B squared. So what is, we're going to plug it in there just like it is. let's see, square root, the perfect square, that's easy for me to say. What is that, 16 plus 1? Square root of 17? Okay, so the way you would write it is you would write it, the magnitude of 4 plus I is equal to the square root of 17. Okay? It looks like the absolute value of this complex number is this. Do you remember me ever telling you the absolute value is distance? Do you ever remember learning that? Well, on a number line, here's 0, here's 2, here's negative 2. Well, your distance from 0 to 2 is the absolute value of 2, which is 2.
Okay.
Your distance from 0 to negative 2 is also 2. It's this distance measured from 0. That's another way to think of absolute value. Okay? So it's totally fine when you think of absolute value being distance that the absolute value of a complex number would be a distance. Are you alright with that one?
Yes.
Let's do our next one. Can I erase all this? Negative 3 plus 2i. So again, we're going to want to find out what a is and what b is, and then do our square root business. What's a?
Negative 3.
What's b?
2.
Okay, so we're just going to plug them in. Negative 3 quantity squared plus 2 quantity squared. So what does that become? 9 plus 4? Square root of 13. Make sure that you put this parenthesis around there, because if you had made it negative 3 squared, it would look like negative 9.
Yeah.
And that's all bad. Okay? So on this one, your absolute value of this puppy is going to be your square root of 13.